3, 2, 1, here we go. Today, you want, oh, and so if people are looking for lessons to be posted, today I do get my prep. Yay, I haven't had my prep since the semester started, I don't think. Just people, like yesterday I had a sub for an 8th grade class. Did I tell you about that?
No.
A sub for 8th grade yesterday, it went fine. It went fine, so anyway, but today I actually get some time, so I'm gonna get stuff uploaded, okay? So, right triangle trigonometry, what we wanna be able to do today is, given this is a 90-degree angle, and given another angle in the triangle called theta, we want to be able to solve for missing parts of the triangle. And there's a relationship that exists with sine, cosine, and tangent in our right triangles. I'm going to draw the angle right here. Okay. Every triangle has 3 sides to it if it's a 90-degree triangle. One is the opposite, one is the adjacent, and one is the hypotenuse. Okay? Which one is this one right here? This is the hypotenuse. The word opposite means that it's across from the angle. So if you take the angle and you go across from it, this side is the opposite.
How do you know you don't do the other?
So if the angle, excellent question, if the angle is up here, then that side would be the opposite. It's dependent on where the angle is placed. The word adjacent, okay? So Cyrus is sitting adjacent to Hannah right now. Adjacent means next to. So which leg is next to the angle? You can tell this opposite side is not next to the angle. This side right here, adjacent, this is next to the angle. Adjacent. So we define sine of the angle to be the opposite over the hypotenuse. We define cosine to be the adjacent divided by the hypotenuse. And we define tangent to be the opposite divided by the adjacent. This is the point where your teachers probably in geometry told you this little word or phrase. So, ka, toa. Okay? And so what does SOHCAHTOA mean? It's divided into 3 parts. The black part, the red part, and the purple part. The black part is for sine. Sine is opposite over hypotenuse. That's why it has an O and an H. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. That tells us this information right here. Everybody got it? Good. So we're going to kind of move around our notes a little bit just because we do have expecting a snow day tomorrow. So we're going to try to make good time here. We're going to do this problem. We're going to skip a few. But we're going to say that we're going to change that from 7 to 8. It says find the exact values of 6. We're not going to do 6. We're just going to do 3 trigonometric functions for theta. We're going to place theta right here. And we're going to say that the legs of the triangle have length of 15 and of 8.
Wait, is it 3 or 15?
So find the exact values. 6 trigonometric functions. We're just going to do 3. We're going to do sine of theta. We're going to do cosine of theta. And we're going to do tangent of theta. We're not going to do cosecant and cotangent and secant. Okay. Nope. So now I look at my triangle and I try to label the sides. 8, is that the opposite, the adjacent, or the hypotenuse? This is the opposite. 15, is that the adjacent or the hypotenuse?
Adjacent.
That's the adjacent. So if I know the opposite and the adjacent, which one of these three can I label right now? Tangent. Remember that tangent is the opposite over the adjacent. So I know right now by this information, tangent is 8 over 15. In order to find the other two, I have to know the hypotenuse first, don't I? How would I figure out the hypotenuse? Use the Pythagorean theorem. Excellent. So we have 8 squared plus 15 squared is equal to c squared. 8 squared is 64. 15 squared, 225 is c squared. 64 plus 225 is 289. And the square root of 289 is 17. 17 is my other side. See if you can write the answers for sine and cosine now. Try to write the answers for sine and cosine. I've got 8 over 17 and 15 over 17. Any questions there? Good. Make sure you got your calculator out. Going to need for this part. Flip it over. We're going to do these 3 problems. And we're going to move to making sure you can have success on your assignment. One of the most helpful things that trigonometry can do is it can find missing values of a triangle, even if you don't have two of the sides. If you just have one of the sides and one of the angles, you can find the missing components. So I look at the triangle. This is 42 degrees right here. Okay? Notice I'm given the side of 9. I'm given an angle 42. I want to be able to find x. What I do is I examine it and I say, first of all, is 9 the opposite, the adjacent, or the hypotenuse? 9 is the opposite. How about x? Is x the adjacent or hypotenuse? Hypotenuse. So if you look at so, ka, toa, you now have to try to figure out, are you going to use sine, cosine, or tangent if you're given the opposite and trying to find the hypotenuse? Sine. Notice how sine involves the opposite and the hypotenuse. So therefore, I choose sine. Yeah?
Yep.
Okay, you just gave that look for a second.
Yep.
Opposite and hypotenuse, that tells me I choose sine. So I write sine. And it's the sine of 42 degrees. Is equal to, do I write it as x over 9 or do I write it as 9 over x? 9 over x because it's opposite over hypotenuse. So sometimes x will be in the numerator, sometimes it will be in the denominator. Now the best way, and if you find a different way, it's okay. You can do things your way, but as I teach the whole class, I tell them to write it over 1. And I tell them to convert sine of 42 into a decimal. So if you have a calculator, that would be great. If you don't have a calculator, you got to take out your phone. Please make sure that everybody at this time comes up with the correct decimal for sine of 42. I press sine, and I press 42, and you have to come up with 0.6691. If you are not getting that, let me know, because we have to see.
Okay, so your calculator is radians. Try it.
Okay, so press mode, and then go into degrees instead of radians. Are you borrowing from somebody?
No.
Okay. Are you borrowing from somebody? So the key is sometimes people borrow a calculator from calculus class. Calculus class is always working in radians. Most of the time you guys are working in degrees. And it hurts when people try to get mixed up back and forth. That's what you got. Okay.
Wait.
What?
Come on.
You can measure out right now.
This is my homework.
Okay, I think we got to take care of, everybody will come up with 0.6691. I think if you do it on your calculator, I think you have to press 42 first and then you press sign. Okay, so I go back to my notes. I've got 0.6691 over 1 is equal to 9 over x. So now you just want to cross multiply and solve. 9 times 1 is 9 is equal to 0.6691x. And what do I do there? Divide by?
0.6691.
Yeah, so your answer is going to be 9 divided by 0.6691. And I get 13.45. And so we found the missing side.
How far do you want us to go in like the decimal places?
I really appreciate to the 100th. I think when you write out your trig value, it's good to write out to 4 places right away. And your final answer, I appreciate 2. If you're within 100th or 2 on your test, I don't care. That's fine. It's when you start being off by tenths, then I start to look back at your work. As long as your work is fine, I'm okay with it. But, you know,
Do you want us to round or just cut it off?
it's fine. Either way is fine. Okay, the next one. Let's check this out. I'm going to draw my angle. What is 14? Is 14 the opposite, the adjacent, or the hypotenuse? Yeah, 14 is the hypotenuse. How about x? Is x the opposite, or is it the adjacent?
Adjacent.
X is the adjacent. So am I going to use sine, cosine, or tangent? I use cosine because it's the adjacent and the hypotenuse. Cosine is the option. So I have cosine of 63 is equal to, is it x over 14 or 14 over x?
Over 14.
It's x over 14. Again, I like to write it over 1. I come up with a decimal and I cross multiply. So as I go to my calculator, I have the cosine of 63. Make sure you're coming up with 0.4539. .4539 is equal to that x over 14. I cross multiply, x times 1 is x. And then I get 14 times 0.4539. And I get 6.35. Last one, then we go to our assignment to practice. I want you to quickly on your own see if you can label these opposite, adjacent, or hypotenuse. See if you can on your own decide opposite, adjacent, or hypotenuse. Okay, check it out. I labeled the two sides as opposite and adjacent. If we have a question, I'll figure out opposite and adjacent. Okay, do you sine, cosine, or tangent? Tangent involves opposite and adjacent. You can see right there. So I set the tangent of 27 degrees is equal to what over what?
9.4.
Is it 9.4 over x or is it x over 9.4?
X over
Again, it's opposite over adjacent, so it's x over 9.4. I'm going to turn tangent of 27 into a decimal. And I get 0.5095. You cross multiply, you get x is equal to, and 9.4 times 0.5095. For those of you who have a calculator, I'm going to show you something interesting you can do here. You could just do a second answer, and that brings the answer right there, times, was it 12 we're multiplying by? 9.4?
Yeah.
And you get 4.79. Not too bad? Okay, so we have to make sure you're ready to have success on your assignment. I want you to open up to this assignment right here. You're going to be doing the front page today, not the back page. The back page is what we'll be doing on Tuesday. So please look at the front page. Everybody see the triangles there? Problem 1 involves a 37-degree angle. It's exactly the same as problem 6, so you just have to do it once. Please, right now on your own, please try problem 1. Please try problem 1. Right, so now I can sign. Okay, and so by the way, so this right here, this side is the opposite. So it's at the cross from the hypotenuse of the bulging side. That's the hypotenuse, that's okay, everybody pause here. If you take a trigonometry class, and somebody here's you take a trigonometry class, they're going to expect that every single person was able to solve right triangles using SOHCAHTOA. This is one of the most fundamental pieces. So we're going to take our time to make sure we get it right. Let's talk about some of the mistakes. A couple of them came up that I saw from people. I want to make sure we talk about them right now. This is your angle. You got to see that this is the hypotenuse because it is the longest side, and then this is the adjacent. Notice how 37, that across from it, this would be opposite. We're not concerned about the opposite, are we? So do we choose to use sine, cosine, or tangent? Cosine involves the adjacent and the hypotenuse, so I have the cosine of 37 is equal to, and it's adjacent over hypotenuse, so it's 11 over x, okay? We go ahead and make a decimal. I got the cosine of 37, and I get 0.7986. So 0.7986 over 1 is equal to 11 over x. When you cross multiply, you get 11 equals 0.7986 times x. So we divide both sides by 0.7986. And what did you come up with, folks? 13? 13.77. Now, here's the key where you want to be able to figure this out, okay? In first hour, somebody flipped the 11 and the x, and they made it x over 11. And instead of coming up with 13, they came up with, say, 8.6. As you look at it, is it possible for this side to be a length of 8.6? Why?
Because it's longer.
It has to be the longest side. So you know right away that this answer must be bigger than 11. You see that? That's the way you can check and verify some of your results. So the last thing we're going to do is you're going to jump to problem number 7. Okay? And then I'll let you guys work about 10 minutes for the rest of the hour. We've got the answer key right up here. As you look at problem number 7, what makes this different?
There's no angle.
Yeah, you're trying to find the angle. So we start by labeling things again. We can see that 13 is the hypotenuse. Is 12 the opposite or the adjacent? 12 is the adjacent. So, am I going to use sine, cosine, or tangent? Cosine. And instead of typing a number, we just use theta. Cosine of theta is equal to, and it's adjacent over hypotenuse, so it's 12 over 13. Now, notice how in this case, we don't have a variable on the right side, do we? We got a variable on the left. When that happens, you just do something a little bit different. If you turn to your calculator, make sure that you come up with this. I don't press cosine. We don't press cosine. We press second cosine. This cosine inverse thing that you see here with this -1, that means that we're finding an angle instead of finding a side. So whenever you're finding an angle, you press second. And then we just type in that 12 over 13. And it will tell us the angle. So it turns out that 22.61 or 22.62, that's the angle if those are your two sides. So theta equals 22.62 degrees. Whenever you're finding an angle, make sure you write the degrees. So your first 6 problems, you're finding a missing side, and then your bottom 4 problems, you're finding an angle, okay? Go ahead. You guys have about 13 minutes. Answer key is up here. I'm going to check to make sure everybody can get started. Definitely want to be able to do this skill.